Welcome everyone to Physical Science. Today we're going to be talking about acceleration. Some of you guys do too much of this, so please watch out and be safe. All right, so acceleration occurs when some things happen. Well, that kind of goes without saying, but acceleration occurs when an object, one, speeds up, because you accelerate. So what you know of is acceleration. And when you put on your accelerator, or you accelerate your gas and you're speeding up. But what you didn't know is acceleration can also be when you slow down. There's a specific type of acceleration called deceleration, but acceleration is still slowing down. So it's changing your speed. Or changes in direction. If you turn around, that is also acceleration. So if you change the direction of your motion. So we have a formula for acceleration, and we are going to use our triangle to work out the formulas just like we have in the past. So A is acceleration. We remember that V is velocity, and T is time. And our formula for acceleration is acceleration equals my change in velocity, delta means change, over my change in time. Okay, so let's break this formula down. Let's get our triangle. And remember, anything on the top of a fraction will always go on the top of our triangle. So change in velocity. Anything on the bottom of a fraction will go below it. Change in time, and then what's left over goes in the hole. So acceleration equals change in velocity over change in time. This change in velocity can also be written in a different way. Change in velocity really means how much your speed has changed. To figure that out, you would have to do velocity final minus velocity initial. So what your final velocity is minus your initial velocity. Acceleration stays the same, but change in time means your time final minus your time initial. Most of the time they'll just give you the numbers anyway. So if velocity is measured in meters per second and time is measured in seconds, then our acceleration is going to be measured in meters per second squared. So when we're talking about units, our acceleration units is meters per second squared. So we're going to use this triangle to solve for some problems. All right, our first example, it says a car goes from rest to 20 meters per second. What speed is rest? Well, if you're at rest, you're going 0 meters per second. Notice I am underlining and writing my variables out as I go. So, and then I go to 20 meters per second. So my velocity final, what I end up going is 20 meters per second. My velocity initial, what I started going, was 0 meters per second. And it says in 6 seconds. So my time is 6 seconds. And it says, what is the car's acceleration? Notice before I even deal with the triangle, I'm writing down all of my variables off to the side. So now I'm going to draw my triangle, and I'm going to plug in my values. So acceleration equals change in velocity over my change in time. So I'm going to plug them in. Well, I'm solving for acceleration, so I leave that. My change in velocity is my velocity final minus my velocity initial. My change in velocity is 20 meters per second, because 20 minus 0 is still just 20. And my change in time, it said it did it in 6 seconds. So when I do the math on that, I end up with 20 divided by 6 because it's over 6, and I end up with 3.3, and repeating, but meters per second squared because we have meters per second over seconds. So my velocity, my change in velocity over my change in time. So let's work out another one. A man was running at 3 meters per second. So it says he was running at 3 meters per second. So that's one of my velocities. I'm not sure which yet though. In 4 seconds. It's probably my time. He slowed down, so his velocity is now 1 meter per second. Okay, so I have to think which one is my velocity final and which one is my velocity initial. Well, it says the velocity is now 1 meter per second. So my velocity final is 1 meter per second because at the final point he was going 1 meters per second. He started off running, my velocity initial, he started off running at 3 meters per second. And I know that my time is 4 seconds because it tells me it happened in 4 seconds. So then I plug it in. It says, what is the acceleration? Same triangle is up here. So I'm solving for acceleration. Change in velocity over change in time. So I have my velocity final is 1 meter per second. My velocity initial is 3 meters per second. And my time is 4. So I have 1 minus 3. Uh-oh. So let me redraw the triangle and let me do the math on that. 1 minus 3 gives me negative 2. And I still have 4. So negative 2 over 4 gives me negative 0.5 meters per second squared for my acceleration. Can you get a negative number? Absolutely, because remember we said acceleration can be positive or it can be negative. It can be speeding up or slowing down. And we can even see in the problem that it gives us an example of him slowing down from 3 to 1. So his acceleration is negative 0.5 meters per second. So you may also be able to ask or be asked to analyze a graph of what acceleration looks like, because acceleration is your change in speed over your change in time. If you're comparing time and your speed, you'll notice that this person's speed is increasing over time. That means that they are accelerating. The slope of this line shows acceleration. So in your notes, if you'll please write speed versus time and draw in your x and y axis. So you have your x and your y where time is in seconds. And over here you have your speed in meters per second. And then draw a line. We want to reference back to this later. The slope of the line is the acceleration, how much it is either speeding up or slowing down. And in this case, you're speeding up because you're accelerating. Your acceleration is positive. If it is a straight line, so let's say you have a straight line, that means your speed is staying the same. So if you started off going 3 meters per second, you ended up going 3 meters per second. You didn't stop, it just means that you're not speeding up or slowing down. Your speed is constant. So if you have a straight line, that means you have constant acceleration. You're not changing, you're not speeding up or slowing down. And then if you have a line that is curved, so a curved line like this or this means that you have a changing acceleration. At some points you are speeding up faster and at some points you're slowing down faster. So notice that this one, the speed is not changing very much, and then once it reaches this point to here and here, your speed changes really, really quickly as you go up. Because remember, the closer it is to a flat line, the less there's changing. So again, no acceleration means constant speed. And I want you to put a star beside this. No acceleration does not mean you are stopped. It just means your speed is constant. you will have a flat line or a zero slope, like that, like you drew on your graph. So let's look at some examples and let's figure out what's going on, because you're going to have to analyze whether or not something is speeding up or slowing down. Okay, well this one is showing you that the speed is increasing, so they're speeding up over time, but it's increasing at the same rate. So this is constant increase, constant acceleration. Now, this would be a constant positive acceleration. So your speed is increasing at a constant rate. Now this one, you start off here and you've got a straight line, but it's going down. What does that tell you? Well, your speed is going down as time is passing, but it's constant. So this is a constant negative acceleration, or deceleration if you will. So you are slowing down at a constant rate. Now in real life, you probably won't experience a constant increase in acceleration. When you hit the gas, you're not going to accelerate at a constant rate by nature. And you also, when you hit the brakes, are not going to decelerate at a constant rate. You'll see something like this, where your speed is increasing slowly, so you're starting to drive, and then your speed as you hit the gas is increasing faster and faster and faster. So this would be an acceleration, but it is changing, and it is positive. So you are increasing your speed, but at a changing acceleration. This one over here, though, you see that you start off going a specific speed, and then your speed starts decreasing really fast, really fast, and then it slows down. So it's not the same acceleration. It's not always a constant decrease. It is an acceleration. And it's changing. It's a changing acceleration. But it is a negative because you are slowing down. So let's look at a graph that you will have to analyze. So I'm trying to figure out which one is moving at a constant speed and has no acceleration. So if you'll please copy in a basic drawing of the speed versus time graph. So do your x-axis and just write time. Your y-axis, and we don't need numbers, just write speed. And then draw in a line like that, a flat line, a line like that, and a flat, or not a flat line, but a straight line going down. And we're going to label these parts of the graph and figure out which ones are which. So right, moving at constant speed. Well, no acceleration. Which one of these is the speed constant? So I look over on my axis and I see that 20, the speed is constant all the way here. It's always 20 right here. So my speed is constant right at point A because it's 20 from here to here. The speed is constant. If I'm looking for a constant negative acceleration, a slowing down, I'm looking for something slowing down but at a constant rate. Well, the only part on this entire graph where I'm decreasing speed at all is from here to here, and it is a straight line or a constant rate. So B would be a constant negative acceleration. So let's look at a constant positive acceleration. Well, between here and here, I'm increasing speed, but at a constant rate because it's a straight line. So C is a constant positive acceleration, or a speeding up. And then the last one we will look at is not constant acceleration, meaning a changing or a variable acceleration. Well, that would be between there and here, because you see how it's not constant, it's not a straight line. So that would be D. D is not a constant acceleration because you don't have a straight, a constant slope, a straight line. All right. I hope everyone has enjoyed, and be careful with your accelerators, and please do not accelerate too much because you may end up sad. Don't hit cars. But have a great day!